All right, integrated 2. So we're leaving trig behind, all that trig stuff that can be kind of challenging, and we're going to jump back to stuff we did just before we left back in March. We actually would have continued with this lesson. I didn't know if we were going to do this lesson or not, that's why I saved it till the end here. This is coordinate geometry, and so we're going to go back to shapes, rectangles, rhombuses, squares, all those good things. Here we have a triangle, and the triangle's vertices are at these 3 coordinates, 1, 6, 3, 1, and 8, 3, and we want to know, is that triangle scalene, isosceles, or equilateral? You could graph it, but even if you graph it, you're not going to really be able to tell if it's a scalene, isosceles, or equilateral triangle. Let's review again what those words mean. First, a scalene triangle, or scalene triangle, that's where all the sides are different sizes. An isosceles triangle means 2 of the sides are the same size. And then finally, an equilateral triangle, all the sides are exactly the same. You could graph it, you could look at it, you might be able to determine, oh yeah, these 2 sides are the same, but we want to know exactly. We want it to be perfect. We're not just kind of looking at it and saying it kind of looks like they're the same. We want to be definitively with our answer and know that this is exactly a scalene, or exactly an isosceles, or exactly an equilateral. So to do that, we need to figure out the lengths of those sides. So we don't have to graph anything. We just need to use our formulas from back in Math 1. One of the formulas that we're going to be using in this lesson is the distance formula. So let's get that distance formula down. Remember that the distance formula is equal to the square root. It's a big, giant square root. It's the square root of the difference of our x's. Technically, it's the second x value minus the first x value, but the order that you put the x's does not matter. And then the same thing with the y's. It's technically the second y value minus the first y value, but again, the order really doesn't matter, and the reason why is because after you subtract them, you're going to square them. And no matter what order you put your x's and your y's in, that answer after you square it is going to be the same no matter what. So what we need to do is we need to figure out 3 different distances, because I need to know the distances, the lengths of all the sides, all 3. So I just have to do this distance formula 3 separate times. So we'll start with AB. We'll choose some different colors here. So we'll do that one in purple. So to get AB's distance, I'm going to put down that I'm doing the distance for AB. So instead of going D, I'm going to put AB without a line over it. Remember, without a line, that means that you're doing the distance. And so AB's distance, we're going to do the square root of. I need the 2 x values for A and for B. If we can look up at the top there, we see that A and B, their x values are 3 and 1. It makes no difference what order I put them in. I can go 3 minus 1 or 1 minus 3. It will give me a different answer, but after I square it, it'll come out to be the exact same thing. Plus my y values are 6 and 1, so we'll do 6 minus 1 squared, just like that, and then we just work that through. So 3 minus 1 is 2, so that's going to become 2 squared. 6 minus 1 is 5, so that'll be 5 squared. If we square those out, you got to square them next, right? Order of operations, exponents come after parentheses. 2 squared is 4, and 5 squared is 25, and then finally I can add those together, and I get the square root of 29. That's the exact answer. If you want, you could grab your calculator and punch that up and get a decimal, and as a decimal, that's 5.39. Now that alone tells me absolutely nothing. I have no idea if I have an isosceles, a scalene, or an equilateral triangle, just having one distance. You have to do other distances as well. So now it just comes down to rinsing and repeating. So now that I did AB, the next one I'll do, I'm going to go ahead and go AC next. Again, no bar over it means I'm finding the distance. I'm going to use the distance formula again, and so this time I'm going to use A and C. Their x values are 8 and 1, so we'll do 8 minus 1 squared. And then the y values are 6 and 3, so we'll do 6 minus 3 squared. The order that you're going to do the operations is not going to change. You're going to work in the parentheses first. 8 minus 1 is 7, and 6 minus 3 is 3. Then you'll square out those numbers. 7 squared is 49. And 3 squared is 9, and that adds up to be 58. If we want the exact answer, we could leave it just like this, the square root of 58. Since I did a decimal in the last one, I'll do a decimal here as well. Punching that up on my calculator and rounding, I get 7.62. So now I have some information, but not all the information. I know one thing right now. I know that it's not equilateral because those 2 measurements aren't the same. But I have no idea if I have a scalene or an isosceles yet because I don't know about that third side. Maybe that third side matches one of these and it's isosceles. Maybe that third side is totally different and it's scalene. So we have to go through and do a third distance formula. We have to find the length of side BC. Still works the exact same way. You're still going to do a square root. You pick your x values, 8 minus 3 squared. Then you do your y values, 3 minus 1 squared. Again, the order that you put those in makes no difference. The reason why that order doesn't make any difference, let me make sure I explain that here. 8 minus 3 is going to be a 5, and that's going to give me 5 squared, and 3 minus 1 is 2. That's going to give me a 2 squared. If you were to switch either one of those orders, if you switch the first order, that would be a negative 5. If you switch the second order, that'd be a negative 2, and you might be saying, Krieger, negatives are different than positives, and you're absolutely right. But here's the next step that makes everything go okay. The next thing you do is you're going to square those. If we do 8 minus 3 like we did here, we get a 5, and 5 squared is 25. If you were to flip that order and go 3 minus 8, 3 minus 8 is negative 5, but negative 5 squared, negative 5 times negative 5 is also positive 25, so in the end, I'm good. And then 2 squared is going to be 4, and if that were a negative 2 squared is still positive 4, and so we end up with the square root of 29, and we could punch that on our calculator and get 5.39. Now that we have all three distances, we can look at those distances and we say, hey, I'm noticing something here. I'm seeing that the distance for AB is exactly the same as the distance for BC, and since those two are the same and only those two are the same, we have ourselves an isosceles triangle. Isosceles meaning two sides are the same. So you have to do all the distances in order to figure out if you have an isosceles triangle, an equilateral triangle, or a scalene triangle. It's pretty straightforward, and I didn't need to graph anything. It's just doing the distance formulas that we know. Now, we're going to use this same triangle, and I can do this right up here. So let me just section off this one portion. Drawing a couple of lines in there. So we're going to use the exact same coordinates, but I've got a different question for you with those same coordinates. And poof, like magic, there is the question. Is triangle ABC a right triangle? Okay, so we already determined it's isosceles. Isosceles, scalene, and equilateral, all about the sides. A right triangle has to do with angles. So I can have a scalene right triangle. I can have an isosceles right triangle. You cannot have an equilateral right triangle because an equilateral triangle, all of the angles are the same, and there's no way all the angles could be 90 degrees. They all would have to be 60 for an equilateral. But I could have a scalene right, or I could have an isosceles right. So because this triangle is isosceles, it potentially is a right triangle. So how do I determine it? Well, again, you could graph it and look, but are you going to be able to tell if it's 90 degrees compared to if it's, say, 89 degrees? Are your eyes good enough to tell a 1 degree difference? That's really hard to do. What if it's not 1 degree? What if it's a half a degree? Your eyes really can't determine that. And so we want to be perfect, and so what we're going to do is we're going to try and figure out if we have a right triangle based on what we know about right angles. If I create a right angle, the two lines that create right angles must be perpendicular. And we have a little fact about things that are perpendicular. Let's get that up there. All right, and like magic, the red ink appears. The slopes of perpendicular lines are opposite reciprocals. Those are very, 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 very big, important words there. You got to have both. Opposite meaning one of them would be positive and one of them would be negative. Reciprocal meaning the fraction would flip. If I have a fraction of 4 over 7, then the other slope would have to be negative 7 over 4. Opposite reciprocals. We should know this. And so what I need to do is I need to check the slopes of all three of my sides. If any two pairs of slopes are opposite reciprocals, then I've got myself a right triangle. If none of the pairs are opposite reciprocals, then I don't have a right triangle. That's all that we have to determine. So, just like we did with our distances, I'm going to look at each individual pair of coordinates. So first I'm going to look at AB. I don't want to find its distance, so I don't want to say AB equals. I'm finding the slope, so I still need to say M, but notice I'm labeling it as AB off to the side there so I know which slope I'm looking at. Recall our slope formula. I should probably put that up here. Let's get that right up at the top. Our slope formula, M is going to be equal to Y2 minus Y1 over X2 minus X1. We should know that. The order does matter, but it doesn't matter as far as making the second y be the first one, and then the first one, and then subtracting the first one. As long as you preserve the order, meaning whatever y value you pick to go first in the numerator, that same matching x value has to go first in the denominator. So as long as you keep that, the order doesn't matter as long as the order is the same. Make sense? Good. So for AB, if we look at the y values are 1, a 6, and a 1. And so I'm going to go 1 minus 6. So I did point B minus point A's y value. So when I go to the denominator, when it comes to the x's, I have to use B's x value first, which is 3, minus A's x value, which is 1. Right? You can't change that order at that point. And so then we do that work. It's not too bad. 1 minus 6 is negative 5. 3 minus 1 is 2. And I'm just going to leave it as a fraction. And there we go. Just like before, that tells me absolutely nothing by itself. I need other slopes to be able to compare. So the next slope that I'm going to find after I do AB is I'm going to go ahead and find the slope for AC. And so again, I'm going to note that I'm finding the slope for AC, but again, I'm not saying AC equals because I'm actually finding a slope, M. If we look at A and C, the y values, I'm going to go with the y value at C first, so 3 minus the y value at A, 6. Then when I do the x values, I have to do 8 minus 1 because of the order that I chose for the numerator. When I subtract those, 3 minus 6 is negative 3, 8 minus 1 is 7. So when I compare the slope for AB and the slope for AC, I notice those are not opposite reciprocals. They're not opposites at all, and they're not reciprocals, so I know AB and AC are not perpendicular. But don't forget about BC. We also need to check that one as well and figure out what that slope is. So that'll be the last one that we need to do. We're going to find the slope for BC. Again, M equals, BC is just my label for so I don't forget what I'm doing. I'm going to grab my y values for B and for C. And so I'm going to grab the y value at C first, which is 3, minus the y value at B, which is 1. And then the x values would be 8 minus 3. When I subtract those, 3 minus 1 is 2, and 8 minus 3 is 5. So now I'm going to compare all three slopes. That blue slope, AC slope of negative 3/7, doesn't match anything. But the other two slopes, our purple slope, AB, and our green slope, BC, if we look at those two are opposite reciprocals. One's positive, 2/5. One's negative, negative 5/2. They're reciprocals, 2 over 5, 5 over 2. And so, because those are reciprocals, yes, triangle ABC is a right triangle. If none of them are opposite reciprocals, then we would say no. Triangle ABC is not a right triangle, but in this case it is. So when you're doing problems dealing with triangles, whether it's finding, is it scalene, isosceles, equilateral, or is it a right triangle, you have to do all three. If you only do two, you haven't done enough. If you've only done one, you've got nothing to compare to. You must do all three slopes if you're talking about right triangle. You must do all three distances if you're talking about scalene or isosceles or equilateral. So on the next video, I'm going to put your last homework assignment, and when you do that homework assignment, you need to do all of the distances and all of the slopes in order to get credit. So make sure you're doing the appropriate work. So until our next slide, have yourself a great day, stay safe, and stay healthy out there.